We're live. Welcome to MAE 106, Discrete Mathematics with Probability. My name is Richard Kaur, and this is Lecture 30. Time sure is flying when we're having fun. There's a couple of announcements that I want to make before we talk about variance. Variance, V-A-R-I-A-N-C-E. 24th. Good morning. Hopefully everyone can hear me speaking. No glitches today with audio. Excellent. Test 3 is this Friday. You get a cheat sheet. That's something. That's get an 8.5 by 11. Just one. You also get a non-programmable calculator. And it should go without saying that this calculator just a second. Okay. I'm just fixing the choppy. Okay, perfect. Nice and smooth. Okay, it should be a little bit better now. So again, it's a non-programmable calculator, and it should go without saying that it's not allowed to communicate with other devices. Communicating. Should also say people and devices. Yes. Okay, sorry. Send me an email. I make sure that everyone has it. So if you haven't got it, just send it an email. Thank you. Yeah. Okay. Some things got sent, some things didn't. I don't know when something doesn't work. It didn't send any bounce backs. Okay, so let's talk about I said I was going to talk about life insurance policies before we moved on to variance, but here's the life insurance example. I hope that answers the question. Yep. So a Canadian insurance company is charging $1,000 for a life insurance policy for a Canadian male who's 19 years of age and will pay $150,000 upon death. Okay, so what the life insurance policy takes into consideration is the probability of death. So now this is $1,000, let's say for the year. So then let's say that we have a probability. We can actually look this up in the Statistics Canada. So the probability that a Canadian male who's 19 years old dies at 20 or the following year or before his birthday is 0.0007. So then the question becomes, what is the expected gain? What is the expected gain per policy? And by per policy, I mean this policy that they're selling for the company. So we can think of it like a random variable. So let x be a random variable. That is the company's gain. So let's write this out as kind of like a distribution. Oops. So we could write it as 0 or 1, or let's say there could be, from the perspective of the company, it could get $1,000. Or it might have to pay out this $150,000. So instead, it might actually have to pay minus, so instead of a gain, because we're talking about gain, it's going to be minus 149,000. So let's just make sure. Let's write this over here. This is the case where they have to pay. And so you would have the 150,000 and you subtract the $1,000 from that. Okay. So the probability of this happening we know is 0.0007. And then over here, this is 1 minus 0.0007. That equals 0.9993. Perfect. So there's our probability distribution. And we should also note, again, that these are all the values that x can take on. Here we can see that the probabilities sum to give you 1. So just as a note, that equals 1. So it's a probability distribution. And now we can do the expected value of x. So over here, so what we had to do was to do the expected value, what we needed to do was the value x times its probability, and we needed to do this for each of these, and then we sum them. So in this case, it would be, well, maybe I'll write out the formula here. So it's the sum of all the values of x, where we take the value of x times the probability of x occurring. So over here, it would be 1,000 times its associated probability, 0.9993. And then we're going to sum this up. This is the value minus 149,000 times its associated probability, which is 0.0007. So let's pull out the calculator, since we do get to use a calculator for some of these calculations. So I have 1,000, I have 0.9993. Multiply that together. So that's 99.3. I also will have 149,000. Multiplying it by 7. We'll add these together. And so I get $895. So what this means is that for every policy sold, the company expects to gain $895. So our intuition is confirmed. The expected gain is positive because an insurance company is in the business to make a profit. If the company is not satisfied with its gain, what it can do is raise the price of its policy. Okay. Let's do just another quick example. Number 2. Thank you. So this one is kind of an exercise. Let's go with 9.3.10. So this is an exercise from the book. So they start out with a probability distribution. They have 6A, 5A, 4A, 2A, and A. What do you think is the value of A then? Just take a moment and try to figure it out. Remember that this is should be a probability distribution, and so that each of these values, all these put together, should sum up to give you A. Or sorry, excuse me, should sum up to give you 1. Anyone have the value yet for A? Mm-hmm. So yeah, so 18A equals 1, which means that A is equal to exactly, right, 1 over 18. So let's write that out. So again, we just need to sum all of these up. So it's 6A plus 5A plus 4A plus 2A plus A equals 18. Oops, sorry, I'm getting ahead of myself. Where did there's the correction tape. Perfect. So it's equal to 1. We can sum these up. I have 3 plus 4 plus 5 plus 6. That's 18. A equals 1. And then bring the 18 over, or you can think of it as dividing both sides by 18. So now I have the 18 over 18. That just is 1. So that's A is equal to 1 over 18. So that means that probability distribution is, we'll have 16 over 18. So that's equal to, maybe I'll keep it as, so 6 over 18. Let's do 5 over 18, 4, 2, and 1 over 18. For part B, this one would say, find the expected value of x. So our expected value is the value times its associated probability. So what I'm going to do is I'll bring my calculator out. Or, no, I'll write it out. So we'll have the expected value of x is the value. Is there supposed to be a 3 over the 18? A 3 over the 18. Which one? Is there supposed to be a 3 over 18? I don't think so. Can anyone help her out? Or could I get a little bit of more clarification on that question? I thought so too, but there wasn't a 3 in there. Yes, that's right. So 6, 5, 4, 2, 1. Yep. So what we're going to do is we're going to multiply those. So it's 1 times 6 over 18 plus 2 times 5 over 18 plus 3 times 4 over 18 plus 4 times 2 over 18 plus 5, 118. So we get 6 over 18, 10 over 18, 12, 8 over 18, and 5 over 18. So you can just add those up. You have 6 plus 10 gives you 16. The 12 gives you 28. The 8 gives you 36. And then the 5 gives you 41 over 18. And I do believe 41 is should be prime, right? So we can leave it like that. Okay. So we had talked about the expected value, which gives us that measure of central tendency of the random variable. The variance is another measure to characterize the amount of spread or dispersion around a random variable. So let's look at this one. So basically it's just another characteristic. Basically it's talking about the spread of a random variable. Because you can have a random variable that has the same expected value, but it's distributed differently. So with the expected value and the variance, you can kind of get a better idea. So for example, I could have something like this. And so over here, I'm going to have the random variable x. Over here, I'll call this y. I'll use this k value over here so I can, and here's the probability of y equals k. So for instance, I could have, let's distribute this at a half. So you can get there we go. Something like that. And we can quickly add this up, right? This satisfies being a probability distribution because 1/2 plus 1/2, that's a whole. And over here, let's say we'll do a quarter. This also is a distribution because for these 4 values that I've plotted here, the 3, 4, 5, 6, it's a quarter, a quarter, a quarter, a quarter. So there's 4 quarters, that makes $1. I mean, makes 1, right? So these are both probability distributions. This is the probability distribution for x. and probability distribution for y. Now, if I do the expected value, here's x. So again, it's the value times its associated probability. So I have 4 times a half plus 5 times a half. So you get 4 half plus 5 halves. 4 plus 5 is 9. Okay, so 9 halves. And if I go over to do the expected value of y, again, it's the value associated with its probabilities. So 3 times a quarter plus 4 times a quarter plus 5 times a quarter plus 6 times a quarter, which means that it's 3/4 plus 4/4 plus 5/4 plus 6/4. Okay. So 4 and 5, that's 9. 9 plus 6 is 15. 15 plus 3 gives you 18. If I divide this by 2, oops, we go and get 9 halves. So in this case, you can see that the expected value of x and y are the same, but they are visually different. When you look at the graph, they're more spread out. So that's what we want. We want some sort of a value which will tell us how much from the expected value, kind of that central moment, or that central point, how far away everything is spreading. So let's just, I'll write this out in words. So to describe the spread or the dispersion, we calculate the expected value of the distance from that expected value, and we square it. Squaring it keeps it positive. Or I should say non-negative, because it could be 0. So this is what the variance means. So you can write it as, some people will write it as sigma squared. Some people can write it as variance of x, var of x. But let's just write this out in words. It's the distance, it's the expected value of the distance from x squared. So we'll take x minus the expected value It needs to be all squared. And the last part is the expected value. So this is the variance. So over here is, you can think of it as the distance between the value x and the expected value. We square it, and we want to know what that expected value is. So this will look, what that means, let's write this out more explicitly. So for all x, we have the value of x minus the expected value. We square that times then its probability. So there's, you can think of it as, these are kind of just different ways of expressing the expected, or sorry, the variance. Okay. If there's 3. So if I go back to our example that we were running with this, we can actually calculate our variance then for this. So we're going to calculate the variance. So going back here, and so what I need also is, so it's the variance is equal to all the values x. So it's going to be x minus the expected value squared times its associated probability. So you notice that the first thing that we need to make sure is that we have the expected value calculated, which we have already done. So this is good. So what this is that I need to take the value. So I have 4 minus 9/2. This needs to be squared, and we need to multiply it by its associated probability. So it's 1/2 plus the value minus the expected value squared times its associated probability. Okay. Let's see, maybe So what I'm doing is just, okay, isn't y 1/4? Oh, no, I haven't done the variance yet of y. I'm just calculating the variance of x. We're going to do the variance of x, and we're also going to do the variance of y. So this is just the variance of x. Oh, the last number? Okay. No, this is, so I'm just calculating the variance of x. Yep. And in this case, we were using the distribution was 1/2. Okay. So I get -1/2 squared. So the nice thing is when I have a negative, this becomes positive. So I'll have 1/4 times 1/2, and 1/4 times 1/2. I have an 1/8 and an 1/8. Gives me 2/8. Or, whoops, I have gone off the page. 1/4. There we go. So there is the variance of x. Now we can move on to do the variance of y. So I'll write the formula out again. So the variance of y. So it's all the values of y. So we'll have y minus the expected value. And we'll square this times its associated probability. Okay. So this one would be the value minus the expected value, so 9 halves, and we're going to square this. And then, yes, you're right. For this one, we would then use the probability, its associated probability, which is 1/4, plus, we have 4 minus 9 halves, square that, times 1/4, plus 5 minus, oops, the expected value, 9 halves, squared, times 1/4, plus 6 minus 9 halves, and that is still 1/4. So I'm just writing it over a common denominator. So 6 minus 9 gives you -3. I'm just slowly working my way through, just calculating all those. So, has anyone got the answer yet? Have they already punched it in a calculator, or? So I have 3 squared, which is 9, and that would be 4. Plus, I'll have 1/4 times 1/4. Again, 1/4 times 1/4. So again, 2 squared gives you the 1/4. 9/4 times 1/4. So you get 9/16 plus 1/16 plus 1/16 plus 9/16. 19 and, 9 and 9 is 18. 18, 19, 20. Okay. So that's approximately 1.25. And over here, this is 0.25. Oops, I shouldn't say approximate, it is. That is equal, and that is not an approximation, it is equal. So those are the two numbers. We have the variance is 1/4 and 1.25. So what I can do is I'll write just, here's this point. That's 4.5. That's the expected value. And over here, again, still the same expected value. But the spread, the variance of how far it is from here, they call that, so we'll have the variance is equal to 2.5 or 1/4. So to do that, we have 4. So this would be like 4.75 here. Over here would be 4.25. So you can kind of see that's kind of the idea. There's kind of the spread around the expected value. And the variance of y, I had written it on the other sheet right here, which was 1.25. So you would have 4.5, and so you can have it on the right hand side would be about 7.5, 5.75, And on the right-hand side, you would have 3.25. But this is what it's trying to do. It's trying to say, like, the probability is around this area, and how much spread away from its expected value it is. So with those two numbers, the expected value and the variance, you can have an idea of where it is located and how much spread it is. I don't quite understand the spread of the value. So just visually, you can see that a lot of the probability is grouped around the expected value here of 4.5. So this is the example we were using. You can see that you have quite a lot of probability that is grouped near it. So in this case, it's quite tight around 4.5. Whereas over here on the right-hand side with a different random variable, it does have the same expected value as the previous one. However, we've spread this probability over a larger distance. So this has more spread. Means more variance. So it has a higher value. Over here, less spread means smaller variance. And it reflects it in that number. And that's why we were introducing this idea of variance, because the expected value kind of gives us a target or a central area in which all the probability will group around, but we need to know how much it's spread from it, and that's what these two numbers help us with. So okay, we've reached the end of the lecture. I will post these notes after this lecture, so feel free to download these notes. And I would recommend at least trying to do 9.4 here. So try an exercise. So try 9.4.1a. Thank you, everyone, and have a great day.